In this video, we're going to take a look at a couple of word problems that involve proportions. So let's get into this first word problem, and really before we start reading it, let me just give you this big overall idea of how to approach proportion word problems. When you have proportions that are involved in word problems, you want to make sure that you are matching corresponding parts of what you're discussing in the word problem. So I will show you what I mean in this, but just again, remember this. If you don't remember anything else from the video, the corresponding parts have to match together logically. And I'll show you what I mean throughout here. The image on your tablet, could be cell phone, but we'll go with a tablet, is currently 4 inches wide by 10 inches long. I guess it couldn't be a cell phone if it's 10 inches long. You shrink the image so it is now 3 inches wide. What is the length of the image now? Here's what I mean by corresponding parts. If we just draw the picture here, we've got 4 inches wide by 10 inches long, 3 inches wide by some unknown amount. So I'm going to call that x. That's going to be my variable because I don't know how long that new image is going to be. What I mean by corresponding parts though is we have ratios that would compare the width to the width and the length to the length. Those would be corresponding parts. So since we shrunk this down, the ratio of this side to that side needs to be the same as this side to that side, right? When you shrink something down on your phone, it's not like the picture, one part of the picture gets much, much smaller and another part stays the same. Everything gets shrunken down at the same rate. So I look at this and I say the width of the larger picture compared to the width of the smaller picture or image is 4:3. That ratio of bigger picture to smaller picture will be maintained on the right side of the ratio. So we would have bigger picture or a bigger image, which is 10 inches, compared to the unknown amount x in the smaller. So again, here I went bigger to smaller. Now what I have left is just to solve out that proportion. So I'm going to cross multiply 4 times x, and then 3 times 10. Which is equal to 30. So 4 times x, 3 times 10. Then I've got an equation to solve out. I divide both sides by 4. And what I'm left with when I solve that out, I have x is equal to 30/4, which does break down if you divide numerator and denominator by 2 into 15/2. So as a mixed number, that would be 7 1/2 inches. So the length of the new image, or the current image, is now 7.5 inches. All right, that's how we do that part of the problem. I do want to show you that we could do this problem by setting up a slightly different proportion. We could also look at the ratio and say, well, the ratio between the width of the bigger image and the length of the bigger image is 4:10. That would be width of bigger image to length of bigger image. And now we'll go to the smaller image. The ratio there would be the width of the smaller image to the width of the length, I should say, of the smaller image. So we're going width to length, width to length. Then we can cross multiply. Now before I do that, I notice I can reduce 4/10, divide numerator and denominator by 2 to get that is 2/5, and that's equal to 3 over x. And then I'm going to cross multiply 2 times x, 3 times 5, which is 15. Divide both sides by 2, and ooh, look what we get, the same answer. And that's no surprise, because that answer comes from paying attention to the corresponding parts, what I mentioned at the beginning of the video. Whether you go bigger picture to smaller picture, with their corresponding widths, and then length to length, or staying with the bigger picture and doing 4:10, width to length, and then going to the smaller part, width to length. Either way, we're being consistent, so we will get the same answer. Stay tuned, I've got another type of word problem just on the other side of this clip. I'm stoked for it. And here we are, as promised, with a second word problem where we're going to use proportions to solve it. Let's see just how proportions apply. The situation is that we have the price of 2 movie tickets is $21.50. We're asked to find what is the cost of 5 movie tickets. Notice in this problem how we have a situation where we're basically given 2 different kinds of units, and there's a rate involved here. You basically have $21.50 per 2 tickets, or 2 tickets per $21.50, depending on how you want to look at it. Then we want to figure out what the cost is of 5 movie tickets. So we want to have an equal rate of cost per 5 movie tickets to the rate of what it is with cost per 2 movie tickets. Because the cost of each movie ticket should not be different if we're all buying the same ticket. So I'm going to start out with that main idea, that you should have the same rate. So you're looking at cost per number of tickets. And I'll write that number of tickets. Now, you could also look at it as number of tickets per cost. There's no reason why we can't set up our proportion that way as well. So we want the rates to be equal. I'm going to set up my proportion that way and use this as my basic plan or blueprint of how to proceed. So the cost of 2 movie tickets is $21.50. I'm going to write that as 21.5 because we're just dealing with numbers here, divided by 2, because again, we're doing $21.50. And you know what? I'm going to change my mind there. I'm going to put the units for dollars and then 2 tickets, just so that we see how the units align in both proportions, or both ratios. So now we've got $21.50 per 2 tickets. The rate needs to be the same on the other side. Now, we don't know what the cost of the 5 movie tickets is going to be, but we do know that we're going to be comparing cost, which is some unknown X, to the number of movie tickets. Again, we need to stay consistent with our ratio on either side in terms of the units. We're comparing cost per ticket. That's going to be the same on the right-hand side of cost per ticket. So now what we have is a proportion. So in my head, I'm ignoring the tickets and the dollar sign. I'm just cross-multiplying as usual. So I'm going to multiply 5 times 21.50. So I've got 5 times 21.50. That's just simple cross-multiplication, equals 2 times X. Now from here, let's simplify 5 times 21.50. That's, I think, $107.50 or 107.5. And what we're left with is an equation where we need to solve for X by undoing multiplication. So we divide both sides of the equation by 2. When we do that, we'll find the value of X, which is the cost of 5 movie tickets. So 107.5 divided by 2 is going to be 53.75. So I would say that the cost of 5 movie tickets is $53.75. One thing you could do to jazz up the formality or just how, well, formal you're writing this out is we could define our variable to start, right? So we could have said that X equals the cost of 5 movie tickets. I think that that makes this problem a little bit more jazzed up and a little bit more formal. So there you have it, y'all. Another word problem that involves a proportion to solve it, and those proportions come in handy where you have 2 different units involved. In this case, we had dollars and number of movie tickets, and you're missing one of those unit values out of 4 total places we could have it, right? 1, 2, 3, 4. Awesome application.